For the leader architect, why your organization needs fine-tuned generative AI large language models. I'm sure you've used ChatGPT and wondered how this or a variation could be adapted in your organization. It might have raised so many possibilities with your leadership team. Many companies are exploring the use of generative AI for growth and digital transformation. In this video, I'll stick to LLM generative models and not others like image generation, data synthesis, adversarial decision making for games or war, etc. Large language models are a subset of generative AI that deal with text reading and writing. Here are a few examples of use, though there are many more. Customer service. Generate responses to customer inquiries or route to the right person. Document analysis. Extract key information from contracts, reports, emails, and other documents. Market research. Digest news, social media, and other text sources to identify trends, sentiments, and insights to inform business strategy. Content generation. Generate reports, product descriptions, tweets, emails, and more. Recommendation engines. Make recommendations to customers. Summarization. Distill long reports or articles into concise summaries. Programming. Generate code for snippets of software applications. Generative AI can deliver the following business benefits like increased people productivity, optimized business processes, enhanced customer service, identify new sources of revenue, and so on. In the next few years, large language models will become standard business tools similar to spreadsheets and databases. As you think about your organizational strategy, you'll have to consider where Gen AI can offer a competitive advantage. There's a spectrum of possibilities for using LLMs from the simplest to the complex. From the simpler side, out of the box with apps like Microsoft PowerPoint or Adobe Photoshop. Use prompt engineering on models like ChatGPT or Claude. Invoke pre-built APIs from providers like AWS or Google Cloud Platform. Fine-tune models for your company's specific needs, or you can build your foundational models from scratch. Most organizations will end up fine-tuning already built foundational models, which is what I will cover in this video. Many LLM models exist, from open source to commercial, from small to huge. The differences among them are basically the volume of data they've been trained on, the domain, and the size of the model reflected by the number of hyperparameters. In general, the larger the data set and the larger the number of hyperparameters, the better is the model behavior. For example, Claire has 12 billion hyperparameters, Palm 2 from Google has 137 billion hyperparameters, and GPT-3 has 175 billion hyperparameters, and GPT-4 is even bigger with 1.76 trillion hyperparameters. As an example, GPT-3 is the pre-trained model that was created by consuming lots of text from the internet. Then it went through supervised fine-tuning for a base chat model, and trained further by a reinforcement learning with human feedback to get ChatGPT that we use today. You might need something similar to ChatGPT for your organization, depending on the context and the data. Say your company does medical research. You could use a model that scans all medical research articles, identify the relevant ones, summarize these papers, and catalog it with metadata to speed up your research. So how do you get there? First, you want to use your own private space to protect confidential information. This means that you can download a foundational model to your environment, whether it is on-prem or on the cloud. To use your own data to train the foundational model, you have to first collect the data, prepare the data, train using that data, evaluate the results of your training, and repeat this cycle until you get desired results. For any particular problem, such as your company's intelligent researcher that we just talked about, there are still some considerations and decisions that you'll have to make. Relative to all the internet information that's in the foundational model and that it has been trained on, medical research information is a very small subset. So our fine-tuning should focus on that subset. For any content outside of that subset, our intelligent researcher should ignore and clearly state so. This is called content moderation. For example, when ChatGPT says, "I'm sorry, I cannot answer that question," that means you're asking a question outside its domain. And then there are other considerations such as which tokenizer to use, length of the responses, accuracy metrics, and so on. For the model to focus on the subset, it has to understand what that subset is. This is done by training the model with research data that your company already has. For example, you can use thousands of examples of original papers and summaries that your researchers have created, examples of papers and metadata captured by your team, and perhaps your company's ontology that captures relationships among these research papers. As you can tell, data is a critical part of fine-tuning, and it might take many iterations to get that right. However, that's also your unique data that gives you the competitive advantage. The training process itself is relatively easy and standardized. You would split the data into a training set, a test set, and a validation set, and use a standard deep learning algorithm, which is often offered as a simple API to train the model. You don't need to know the internals of that deep learning algorithm, except for fine-tuning some parameters. After you've created the Gen AI system that you want, you have to integrate it into your business process. I'll cover this topic in a future video. Pick your unique data and pick the right capabilities to enhance with Gen AI. Picking non-differentiating capabilities often is a waste of resources because those can be purchased off the shelf. If you enjoyed watching this video, please consider subscribing. For a one-page visual summary of this video, please sign up on my website. Thank you for watching.